8, exercise 8.2 from your textbook. Question 7. First, we've got a square DEFG. It is cut out from a circular tin plate as shown. They tell us that the diameter of the tin plate is 20 cm, which means that from E to G, we've got 20 cm. And the center dot over here, this dot in the middle represents the center of the circle. So we know that from E to the center will be 10 cm. And likewise from D to F, that is also the diameter, 20 cm. So from D to the center of the circle, another 10 cm. So in that way, we are able to divide this circle into 4 equal parts. And that 4 equal parts corresponds to the 4 equal parts of this square in the middle. Okay, so we're actually joining the diagonals of the square to result in 4 right angle triangles. So, okay, we can skip all this. So let x be the length of a side of the square. X square, 20 cm. Okay, yep, that can be done. So in this case, they let DE be x, DG also be x, and so on and so forth. All of them will be x. We know that x squared plus x squared will be equal to 20 squared. Reason is because this angle EDG will also be 90 degrees. This is part of the square, right? So that joining E to G, the diameter, that will be 20 cm. So we form, they're actually dividing this square into 2 right angle triangles, one on top, one on the bottom. So x squared plus x squared gives us 20 squared. And you'll find that the length of the side of the square is 14.1 to 3 sm. Okay, all that they did was to just separate the square into 2 equal right angle triangles. So that's question 7. Any questions? Alternatively, you can also cut this square into 4 equal right angle triangles. You will still get the same answer. And that's actually what I'll do. I'll take 10 square plus 10 square equals to DE square. Same answer. Okay, next one, question 12. Is it? Yeah, question 12. Okay, so now we have 2 kites that are 50 meters from the ground PQ. So the ground is a horizontal ground. 2 kites, both same height. If the diagram is not drawn for you, you have to be able to sketch it out by yourself. So 50 meters, and they have the length of the string of both kites. One of them 84 meters, the other 67 meters. So from here, we can actually see that there is one right angle triangle clearly drawn for us. Our objective is to find any other right angle triangles. And we can do so by dropping a perpendicular down from A down to PQ. So that perpendicular height will also be 50 meters. And then here's the thing about Pythagoras theorem. You have to be very familiar with the fact that when you are given a right angle triangle and you are given 2 lengths, triangle 3 sides, right? If you are given any 2 sides, confirm can find the third side. Whether it's a longer side, shorter side, middle side, using Pythagoras theorem. So this is one of the instincts that you must develop. Just as every time you see a square, they give you one side of the square, 5 cm. You must be able to tell, oh, the rest of the 3 also 5 cm. I can find all of them. If they give you the side of the square 5 cm, you must know immediately, I can find the area. I just need to square the 5. Same thing, if you are given a right angle triangle and they give you 2 sides, in this case 84 and 50, straight away you must say, oh, I can find the length of PQ already. Not difficult. Okay, these are the instincts that you must have. So I have just described to you the other right angle triangle from A, drop a perpendicular line to PQ. That is also 50. So in my straight away, I can find the distance from the base of the other triangle to P, to the point Q, P, sorry. So if I can get the distance PQ from this triangle, then I can get this distance. It means that I can tell the distance between A and B. just simply subtracting. So that is the plan that you formulate in your mind when you look at the question already. Okay, so with that, actually the solution is quite straightforward already. Construct a perpendicular line down. So as mentioned, they name it N. In the case of a test paper, because the diagram is given to you, you can just indicate N or X, whatever you want to call it on your diagram. So they describe the triangle. Okay, this is not necessary. So we form the first equation with Pythagoras theorem to find PQ. You can skip this part. So PQ square root 4, 5, 5, 6. And in the other triangle, okay, don't need to write this. No, we should. Okay, then Tn square root 1989. Notice that they did not try to find the 3SF value of PQ as well as Pn, because there is no reason to write down 3SF. That would be an intermediate step. In fact, also no point writing 5SF lah. What's the purpose of writing 5SF? No reason, right? I mean, in the past, in step 1, you would write 5SF because of what we taught you. Intermediate step cannot be 3SF, otherwise you'll lose accuracy. Then go all the way. Might as well keep it as square root 4556, square root 1989. No need to round off. And final step is just a subtraction. Let's do this. Get the distance, and you get the 3SF value. Best practice is to only use your calculator at the last part. Whenever that you know in the intermediate steps there will be some irrational numbers, some square roots here and there. This is to preserve as much accuracy as you are able to. Anybody needs more time? If you do, raise up a non-writing hand. Okay, then next one is question 14. Hey, actually, it's a similar question to our notes. Okay, so find the length of the ladder. Again, look for right angle triangles. You can see the triangle PQF clearly. That is the original state that it is in. Right angle triangle. I can see that I have the height, the perpendicular height. I've got a base. That means I can find the hypotenuse using Pythagoras theorem. That is something I definitely can do. Okay, so once I have that, part A is not a problem. Then the upper end, P slides down 0.8 meters, blah, blah, blah. How far did the lower end slide away from its original position? So basically trying to find SQ. So let's look at the resulting triangle. The length of the ladder did not change. So whatever answer you obtain in part A will remain the same length as RS. So we've got the hypotenuse for the resulting triangle. We've got a perpendicular height. How do you know that? It is 2.5 minus 0.8. I have got a perpendicular height. With the two lengths of this new right angle triangle, I can find the base using Pythagoras theorem again. So that can be done. When I have the new base, I just need to subtract 1.2 to get the answer. That will be how much the ladder lead from its original position Q. So that is the plan. And this part A, finding the length of the triangle, finding the length of the ladder. So 2.77 meters to 3SF. This is the one we're going to be using for our resulting triangle. Actually, I don't expect you all to get part A wrong. So I suppose some of you didn't do your homework. You are furiously jotting down stuff. You need to practice by yourself at home. So next one, part B. So in the resulting triangle, the length of the ladder didn't change. So the length of the ladder is still square root 7.69. Look, they didn't want to use 2.77, which is the 3SF value. They didn't even want to use the 5SF value. They chose to use square root 7.69 as the length of the rectangle of the ladder, because why not? It's the best. So find the difference in the height. Find that the vertical height of the triangle is now 1.7. So we're going to apply Pythagoras theorem again. And here's the beauty about having to use Pythagoras theorem twice. Earlier on, our length of the ladder is square root 7.69. When we apply it to Pythagoras theorem again, you are going to square the square root, and therefore you obtain 7.69 as an exact value of RS squared. Imagine if you had used the 5SF value or the 3SF value, you would not get the same 7.69 back, which is an exact value. Okay, so the rest is just simple logic. So a lower end slid 0.991 meters away from its original position, even though the top came down by 0.8 meters. Horizontal distance doesn't correspond to the vertical distance change. Okay, so this is the end of the homework for chapter 8, and your WA3 in week 6 covers until the end of chapter 8. Any questions? Okay, then I've already given you some extra work to do. We'll be using some of the time this week as well as next week as a revision for our WA3. So we left off over here last lesson. For a right angle triangle, identify hypotenuse, adjacent, opposite, based on the angle that they are interested in. If they did not tell you the angle they are interested in, then there's no point for your opposite and your adjacent, because they will change. So in this case, they have identified theta. This particular angle, with reference to theta, AB is my opposite side, BC is my adjacent side. And then I can write down my 3 equations. Sine of an angle. Always trigo, angle. When I say trigo, I mean sine, cosine, and tangent. So trigo, next will be your angle. In this case, theta. So you see, they always start off this way. And they follow up with angle. You will never ever see an equation written like this. Sine equals to. There is no such thing. There is no such thing as cosine equals to. There's no such thing as tangent equals to. It is always sine, cosine, tangent of an angle. So the green color highlighted part, theta is the angle. In Sec 2, we only deal with angles in degrees so far. Once we have that, we will write down the equal sign. Okay, so after the angle comes the equal sign. And then we have the fraction. What goes in the numerator? That depends on which trigo ratio you're talking about. If it is tangent, then O comes first. If it is cosine, then A for adjacent comes first. If it is sine, then O for opposite comes first. So decide what is in your numerator. Decide what is in your denominator. We do so by memorizing the following. Dua, pa, and so. All these fractions on the right, they are literally fractions without units. They are ratios. They are in the simplest form. And then our some presentation. Our sine is abbreviated, short form, SIN. Cosine, the full spelling is on the left. So we've got our cosine, COSINE, is shortened to become COS. Finally, tangent is shortened to become TAN. All of them small letters. No capital letter at all. So we'll try one example here. Find the values of sine theta, cosine theta, tangent theta for the following triangles in fraction. Okay, they are asking you to find out what is sine theta, cosine theta, tangent theta. Once you have memorized your Tuakaso, we are able to write that down already. For example, in example A, sine theta. Okay, this is theta. Sine. So, SOH. Opposite over hypotenuse. What is the opposite side to theta? It is 15. So write down 15 in the numerator. The next in the denominator is H for hypotenuse. Hypotenuse has a value of 17. So you put 17 in the denominator. It's as simple as that. So now, please try part B. Try part B. Okay, compare the difference between your part A and my part A. Sine 66. Did you put on the degree? Did you? If you did, congratulations, you got it correct. If you didn't, oh no, it's absolutely wrong. No degree means it's absolutely wrong, no? Why? Because in Sec 3, you'll be learning a different unit for angles. And that unit for angles doesn't have a unit. Can you imagine? A unit that doesn't have unit. So dangerous. If you are not writing the unit for angle, you are referring to that unit which you haven't learned yet, which is different from degrees. That is why when you are dealing with degrees, you must put down the degree symbol. If you do not have the degree, the one highlighted in green, wrong. Because you are doing something else altogether. So in next question, part B, we have cosine 129 degrees. I always make sure I write it down when it is in degrees. So put it down in your calculator, cosine 129. Straightforward. Oh, it's a negative value this time. 0.62932. So round off the 3SF, 0.629. Do you have any questions about part B? Any questions? No. I'm hoping that some of you ask me questions. Something that should make you feel very uneasy. Why is it negative? Okay. Before that, another question. That's a good question. Why is it negative? I thought the sine, cosine, tangent, they are supposed to represent ratios, right? Ratios of two sides of the triangle. And I thought the sides of the triangles have to be positive, right? We cannot have negative length. So if all three sides of the triangles are positive, then how do I end up with something divided by something equals to negative? That is the question by Harry. Before that, there's one more question. Another question. Something that should make you feel very uneasy. There are only three parts to this. 1, 2, and 3. Harry already identified that the third portion looks a bit weird. Yes. What? Violet? I thought you want to answer no. Okay, go. Yes, John. Huh? Yeah, what about the 129? 129, right angle triangle, right? How can we have a 129 degrees in a right angle triangle? See, any right angle triangle, one of the angles is already 90. How can we have a 129? So these are the questions that I was hoping you all will discover. It's very strange that how come this can happen. Okay, so turns out in our trigonometry, our sine, cosine, tangent, it is not just limited to right angle triangles. We can go from 0 to more than 90 degrees. We can go all the way to 360 degrees. Guess what? We don't stop there. You can continue for another round, 720 degrees. You can go on forever and ever. You can go to any degree you like. You can even go negative angles. That you will learn in Sec 3. Okay? But for now, we still need you to be able to press calculator to find out values of cosine 129. So therefore, if your answer is negative, don't worry about it. It is possible. If you see cosine 129 as an angle, don't worry about it. It is still possible. It's just that it doesn't belong in our usual idea of a right angle triangle. Next one, part C. So part C, 3 tangent 75 degrees. Let me just write down what this means. This means 3 times tangent 75 degrees. So you literally press in your calculator 3 tangent 75. Your calculator knows what it means. So 3 tangent 75 giving us 11.1961. Okay, 3SF 11.2. And the final one, part D. Watch out, all the angles, all the degrees, you have to put on the degrees. And the last one, part D, sine 25 degrees plus cosine 65 degrees. There are actually invisible brackets over here. The brackets are shown. I'm just going to draw them. These are the invisible brackets, which we do not need to write. And you have to take note that these come separately. Okay? It is not sine. This question doesn't mean this. There's a difference. When we write it this way, we are talking about this. Okay, so key to your calculator, be very careful. Sine 25. My habit is that I will press sine 25 and I'll press the equal first. I'm not doing any rounding. My calculator, all the information still stored in my calculator. Then after that, I'll press add cosine 65. And I get the answer as 0.845236. So 3SM, 0.845. Okay, now we really come to the portion where we can determine the angle already. So earlier on, we were able to write out sine theta equal fraction, cosine theta equal fraction, tangent theta equal to fraction. What exactly is the theta? That's what I want to know. We do that by using inverse. Inverse is like reverse, kind of like our converse. So confusing, but never mind. The proper way to say it is inverse. Sine inverse, cosine inverse, tangent inverse. So let's start with part A. Cosine theta. Now you are given cosine theta equals to 0.1353. It's a number. You can treat it simply as a number. This number could have been written as a fraction. Perhaps you were given a triangle and you had 1, 3, 5, 3. You ended up with this. Perhaps you ended up with this fraction in red from this diagram. So this is our theta, right angle, cosine adjacent, 1353, 1000. Perhaps it looked like this. So you said, okay, I've got an adjacent, I've got a hypotenuse, so I write cosine theta equals to adjacent over hypotenuse, and you end up with this fraction. Decimal form is as such. Okay, so this is the situation. And I'm dying to find out what that particular angle theta is. I want to find out what theta is. So far, I've got this. So here comes our calculator. We know it's going to do is cosine. So you press Shift, usually your top left-hand button, the yellow one. Shift, cosine. And what you should see appear on your calculator looks like this. So our calculator display in blue. Cosine with a inverse. Very tempting to call it cosine power -1, isn't it? Looks like power -1, but it is not. It is entirely different from power -1. This -1 in the top is called inverse. It means we are trying to reverse our cosine. Normally, we have cosine of an angle and we give you the angle. Then you tell us the answer. But this time, we want you to find the angle. You need to inverse, kind of like reverse it. So cosine inverse, that is what you see in your calculator with an open bracket. Next, you will press 0.1353. 0.1353. You can close the bracket. You can just press equal in your calculator. 0.1353. And calculator says 82.224. What do you think this 82.224 represents? What do you think it represents? There is only one unknown in this equation, right? Theta. It represents theta. It tells us that this is the value of theta. And does theta have a unit? Should theta have a unit? What does theta represent? It is the angle. Theta is the angle. It has a unit. In Sec 2, our unit is degree. You must write down the degree. You must write the degree. No degree, wrong. And here comes the next key thing to remember. In secondary school, when you're sitting for O levels, all angles are written to one decimal place. Over here. No more 3SF for angles in degrees. And we stress angles in degrees. Why? Because there are other units for angles. For other units of angles, like I mentioned in Sec 3, your radian, you'll be 3SF as per anything else, 3SF. You learn everything, not exact 3SF, not exact 3SF, right? This time, angles in degrees. If it is not exact, you put it in 1 dp. So we have to round off to become 82.2 degrees. So that is the answer for part A. You do not need to end up with a fraction in order to use your cosine inverse. Any number will do. Without this triangle drawn, you can still do everything. 82.2, huh? So that's for part A. So I'll write it out neatly. Theta is cosine inverse 0.1353. So giving us a value of 82.224. Rounded off 82.2 degrees. So this is the presentation for part A. I'm going to continue part B at the bottom. Sine theta 0.6713. So I am trying to find theta. Theta will be sine inverse 0.6713, which gives me a value of 42.167. 42.2 degrees. So now try part C and part D by yourself. So we didn't need to copy down the question all over again. Inverse tangent 3.05. So the answer is in degrees, 71.847. 71.8. And then for part D, theta is sine inverse 0.54. Okay. Homework question, please copy this down. Exercise 9.1, question 3. I think your notes show something else. It shows something from chapter 8, which doesn't make sense. Okay, so this is the correct one. Question 3. Please amend it.